So in Chapter 12, we talk about information systems and program development and designing and building solutions. Our objectives for this chapter are to define system development and list system development phases, identify the guidelines for system development, discuss the importance of project management, feasibility, assessment, documentation, and data and information gathering techniques, discuss the purpose of tasks conducted in each system development phase, differentiate between low-level languages and procedural languages, identify the benefits of object-oriented programming languages and application development tools, list other programming languages and application development tools, and describe the various ways to develop web pages. Information systems are collections of hardware, software, data, people, and procedures that work together to produce quality information that supports daily, short-term, and long-term activities of users. System development is a set of activities used to build an information system, and it's usually broken down into categories called phases. A collection of phases is the system development lifecycle. They consist of planning, which is to review and prioritize requests, allocate resources, and form your development team. Analysis, which is your preliminary investigation, detailed analysis activities. Design, which is acquiring hardware or software and developing system details. And then implementation, which is to develop programs and apps, install and test the system, train users, and convert to the new system. And your support and security, which is your maintenance and monitoring performance and access system security. Your system development guidelines are you want to group your activities into phases, which grouping them into phases will make them easier to accomplish. It breaks the work down, spreads it out, and it makes smaller goals that are more accomplishable and easier to focus on for each group, for each team. You want to involve your users, at the very least, to get feedback on what you're doing and how it works for them and what they might want to see in your information system. And then you also want to define standards. Standards are a set of rules or guidelines to which separate groups and teams must adhere to, and this just ensures consistent and proper results from different groups working on the same task. Your system analyst is a person responsible for designing and developing an information system. They coordinate with representatives from each department in which the system will be used. They're the liaison between the project management team and the IT specialists, usually one that can go between them and take ideas and concepts and work with the IT team to integrate those ideas. Project management is the process of planning, scheduling, and controlling the activities during system development. Larger projects may also have a project leader as well as a project manager. And the project leader manages and controls budget and schedule, while the project manager controls activities during system development. There are certain elements to be identified at the start of a project. One would be the goals, objectives, and expectations. That's sometimes called the scope. It's what the project is meant to do, what the information system is, the whole purpose. Then you have to identify what activities that will require to achieve those goals, the amount of time it might take, the amount it might cost, and then what activities can be done simultaneously to reduce the amount of time taken to complete the project. The collection of those elements becomes the project plan. A project plan is assembled to make deliverables. A deliverable is a tangible item such as a chart, diagram, report, or program file that maps out the project timeline for completion and for other deadlines along the way that may be needed. Project managers often use project management software in order to form and organize deliverables. A couple of examples of a deliverable in chart form would be the Gantt chart and the PERT chart. The Gantt chart is a bar chart that uses horizontal bars to show project phases or activities. The left side, or vertical axis, displays the list of required activities. A horizontal axis across the top or bottom of the chart represents time. A PERT chart, short for Program Evaluation and Review Technique chart, analyzes the time required to complete a task and identifies the minimum time required for an entire project. PERT charts can be more complicated, but are better suited for planning and scheduling large, complex projects. Scope creep is when one activity leads into another one that was not previously planned for. This can mean that maybe some part of the system was completed and maybe the feedback suggested that another idea be integrated into the information system. Project managers will assess whether or not scope creep requires that they either change the deadline and or change the scope so that scope creep doesn't affect meeting deadlines. Feasibility is the measure of how suitable the development of a system will be on the organization. There are a few different forms of feasibility to be considered. One is operational feasibility, and that essentially is how well will the system work for the organization. There's schedule feasibility. Is it even possible to make the deadlines that are listed, that are shown? There's technical feasibility, and that's what softwares and hardwares will be needed, and if the company has them, or how do they obtain them. And then there's economic feasibility, which is how much will developing the system cost. Documentation is the collection and summarization of data, information, and deliverables. Documentation is ideally used to track what happens during system development. It's for recording costs, activities, changes. Ideally, this all happens while the project is moving forward. All too often, though, documentation is not actually recorded until after, or it is put off until the end or until late in the project, near the deadline. And because of that, a lot of times the documentation is flawed. It'll be lower quality. It won't actually reflect what happens, as opposed to if it had been recorded during the system development cycle.
During system development, members of the project team gather data and information. They need accurate and timely data and information for many reasons. They must keep a project on schedule, evaluate feasibility, and be sure that the system meets requirements. System analysts and other IT professionals use several techniques to gather data and information. They review documentation, observe, survey, interview, conduct joint application design sessions, and research. An individual's quality of existence depends upon obtaining quality information. Information literate people know how to locate meaningful resources that can be used to solve problems, make decisions, and set goals. The following 5 categories are recognized as integral literacy components: digital literacy, library instruction, media literacy, numerical literacy, and traditional literacy. Locating appropriate material, organizing these sources, and producing the final document require effort and careful thought. The following paragraphs discuss steps you should take when crafting research, thinking critically, and drafting strategies. You need to establish an appropriate topic, identify the sources, evaluate materials, and create the final work. A user may request a new or modified information system for a variety of reasons. The most obvious reason is to correct a problem, such as an incorrect calculation or a security breach. Another reason is to improve the information system. Organizations may want to improve hardware, software, or other technology to enhance the information system. Sometimes situations outside the control of an organization require a modification to an information system. Corporate management or some other governing body may mandate a change. Mergers, reorganizations, and competition can also lead to a change. Carefully handcrafted letters, as well as long phone calls with friends and family, are rare in today's digital world. Nonverbal digital communications, such as email messages, Text messages and online social network posts have replaced many traditional social interactions. Although people often use these technologies to share thoughts, opinions, photos, and more, there are many questions on whether these types of communications are meaningful.
So next we're going to be talking about the hardware and software requirements needed to create a new or modified system. There are 3 different techniques. Number 1 is request for quotation RFQ. Identifies the required products. With an RFQ, the vendor quotes a price for the listing products. There's a second technique, which is called request for proposal, RFP. The vendor selects the products that meet specified requirements and then quotes the prices. And then there's a third technique, which is called request for information, RFI, a less formal method that uses a standard form to request information about a product or a service. There is a fourth method, and it's called value added reseller, VAR. It's in which an organization that purchases products from manufacturers and then resells these products to the public, offering additional services with the product. There is an IT consultant in which can help with this process, and it's a professional who is hired based on technical expertise, including service and device. They often specialize in configuring hardware and software to businesses of all sizes. Now there's a list of steps in which you test and evaluate the vendor proposals. The first step is acquiring the necessary hardware and software to identify all the hardware and software requirements of the new modified system. And the 3 techniques that I explained, those are part of step 1. Number 2, after the system analyst defines the technical requirements, the next step is to summarize these requirements for potential vendors. And then from there, system analysts send the RFQs, the RFPs, or RFIs to potential hardware and software vendors. And after that, step 4, after sending the RFQs, the RFPs, and RFIs to potential vendors, the system analysts will receive completed quotations and proposals. Number 5, they evaluate the proposals and then select the best one. Once they select the best one, Number 6, sometimes they need to check whether the software can process a certain volume of transactions efficiently. So they use a test called benchmark test for this process. And the next step after that, they have rated the proposals. Once they have rated the proposals, the system analyst presents a recommendation to the steering committee. The next step is to develop detailed design specifications for the component and a proposed solution. The activities to be performed include developing designs for the database, inputs, outputs, and programs. The next step is software developers write and modify programs and apps from the program specification package created during the analysis phase, known as program development lifecycle. And the final step is the final implementation activity, which changes the old system to the new system. The implementation phase is basically to construct or build a new or modified system and then deliver it to its users. The members of this system development team perform 4 major activities in this phase. Number 1, they develop programs and apps. Number 2, they install and test the system. Number 3, they train the users. And number 4, they convert to the new system. Now there is 4 different ways in which you can test the new system. There is unit test, which verifies that each individual program or object works by itself. There's a system test that verifies that all programs and application work together properly. There's an integration test, verifies that application works with other applications. And then there's an acceptance test, performed by the end users, checks the new system to ensure that it works with actual data. And then there's the side part of training, which shows users exactly how they will be using the new hardware and software in the system. Now, converting to the new system, there is 4 different ways to convert. The first one is direct conversion. in this process, the user stops using the old system and begins using the new system on a certain date. The advantage to that is that this strategy requires no transition costs and it's a quick implementation technique. The disadvantage, it is extremely risky and can disrupt operations seriously if the new system does not work correctly at the first time. The second type of conversion is parallel conversion, in which they run the old system alongside with the new system for a specified time. The advantage to this is they allows you to fix any problems in the new system before you terminate the old system. The disadvantage to this is it is costly to operate the two systems at the same time. Phase conversion is a third conversion in which each location converts at a separate time. Pilot conversion, only one location in the organization uses the new system so that it can be tested.
Hello, my name is Nancy and I'm going to talk today about support and security phase. What is support and security phase? It provides ongoing assistance for an information system and its users after the system is implemented. It has three phases, which are perform maintenance activities, monitor system performance, and lastly, assess system security. Information system maintenance activities include fixing errors, as well as improving a system's operations to determine initial maintenance needs. The system analyst should meet with users, which is called post-implementation system review. It discovers whether the information system is performing according to the user's expectations. And then we have the programming languages, which are a set of words, abbreviations, and symbols that enables a software developer to communicate instructions to a computer or mobile device. There is a low level and the high level. On the low level, it's machine dependent, which means it runs only on one particular type of computer device. And the high level is machine independent, which can run on many different types of computers and operating systems. The low level consists of machine language, assembly language, and symbolic address. The high level is the procedural language, C program language, compilers, and interpreters. And that is an example of the low-level language, and it's the machine language, actually. It's an example of the machine language, known as the first generation of programming languages, and is the only language the computer directly recognizes. And here is an example of the assembly language payroll program. The assembly language is the second generation of programming languages. A programmer writes instructions using symbolic instruction codes, and the symbolic address is assembly language. Also use symbolic addresses, which is meaningful name that identifies a storage location. The procedural language, it's the programmer writes the instructions to tell the computer what to accomplish and how to do it. On the high-level language, we have the C language program, which is programming language developed in the 1970s, and it was originally designed for writing system software. And today, many programmers are written in C language, and that is an example of the C payroll program. Then we have compilers and interpreters, which is the translation process can be very complex because of the 3GL source program instructions translate into many machine language instructions. And which is a compiler that is separated in program that converts the entire source program into machine languages before executing it. Then the machine language version that results from compiling the 3GL is called the object programmed or object code. And that is an example of how a compiler converts the source program C into a machine language object program. And this is how an interpreter, it's one line of source program at a time, which converts it into machine language and then immediately executes it by the computer or mobile device. In object-oriented programming language and application development tools, we have the object-oriented programming, which is OOP. It's a language programming language. It's a language programming language used to implement objects in a program. And then, let's see, we have Java. Java is an object-oriented programming language developed by Sun Microsystems. And that is an example of a portion of a Java program and the windows that it displays. We have C++, which is an object-oriented program language that is an extension of the C programming languages. C++ includes all the elements of the C language, plus it has additional features for working with objects. Programmers commonly use C++. Visual Studios contains a suite of object-oriented applications development tools that assist software developers in building programs and apps for Windows or any operating system that supports Microsoft. Other language and application development tools include 4GL, which is the fourth generation language, non-procedural language, and CQL. CQL is a query language that allows users to manage, update, and retrieve data into a relational DBMS. Micro is a series of statements that instructs a program or app how to complete a task. Micros allow users to automate routine, repetitive, or difficult tasks in application software such as word processing, spreadsheets, or database programs. A micro has two ways to create. There's two ways to create a micro. It's record a micro or write the micro. And here is an example of a micro of how it runs. And the web development, lastly, which is web developers designed web pages. And they use hypertext markup language, which is a spatial formatting language that programmers use to format documents for display on the web. And that is an example of how a hypertext markup language works. And they also use XML, which is extensively markup language. It's an increasingly popular format for sharing data that allows web developers to create tags that describe how information is displayed. And we have also scripts, applets, servlets, and ActiveX controls, which is markup languages that tell a browser how to display text and images. They set up lists and option buttons and establish links on a web page. And we also have scripting language, which interprets language that typically is easy to learn and use. Lastly, JavaScript is an interpreted language that allows the programmer to add dynamic content and interactive elements into a web page, which consists of Perl, which is a practical extraction and report language. It was originally developed by Larry Wall and is a procedural language similar to C and C++. The latest release of Perl, however, is an interpreted script language with powerful text processing capabilities. And then we have PHP, which is Hypertext Processor. It's a free open source scripted language. PHP is similar to C, Java, and Perl. That was all, and thank you for watching.